So we're going to talk more about velocity and rates of change again today, mostly velocity, okay? So here we go with first problem and just a lot of questions regarding this, okay? So nothing, no concepts that I need to teach you. It's just applying everything we've already learned, all right? So particle moves along a horizontal line so that its position at any time t is greater than or equal to 0 is given by the function s of t. So this is going to tell us the position, okay, where s is measured in meters and t is measured in seconds. So we put a time in, we know the location of it, okay, on this horizontal line, okay? So the very first thing is find the displacement of the particle during the first 2 seconds. So displacement is the change in position. So we want to look at the change in position from when we start at time 0 to when we finish 2 seconds later. So that would be s of 2 minus s of 0. Okay, so what does that wind up being? Well, if you put 2 into this function, we get out -1. So this would be -1 minus, and what do we get out at 0? We get 3 out, okay? So it'd be -1 minus 3. And I'm just using parentheses to show you this is the position at time 2, and this is the position at time 0. And this would be -1 minus 3. So this comes out to be -4, and then the units would be meters on this. So we're 4 meters to the left of the origin is what this is telling us, okay? So next thing, okay, find the average velocity of the particle during the first 4 seconds, okay? So average velocity is the change in position, which is displacement, over the change in time. So the change, we want to do the first 4 seconds, so that would be s of 4 minus s of 0 all over 4 minus 0. And so s of 4, if we put 4 into this, we get 3. If we put 0 in, we get 3 over 4 minus 0, which is 4. And then 3 minus 3 is 0 over 4. So this gives you 0. Okay, now what are the units on this? Well, the numerator, the units for the numerator, well, these are both position. So the numerator unit would be meters. And this is in seconds, so it'd be meters per second. So the average velocity is 0 meters per second during the first 4 seconds, which means we went an equal amount. It doesn't mean you didn't go, you didn't travel any, okay, and you didn't move. It just means that it could mean that, but it doesn't have to mean that. That's what I'm trying to get at. What it means is that you went an equal amount with positive velocity and negative velocity that canceled each other out, and you got 0, okay? All right? So the next question is this: find the velocity of the particle. So that's when they say velocity, that means the instantaneous velocity at exactly 1 moment in time at 4 seconds. Okay, so that would mean we need to find s prime of t, which is v of t. All right, so if we take the derivative of the position function, we would wind up with 2t minus 4. And then we could find v of 4 by putting 4 into this. So that'd be 2 times 4 minus 4. So that would give us the velocity at time t equals 4 as 2 times 4 is 8, and 8 minus 4 is v4. And the velocity units would be meters per second for this. All right, so then the next thing, okay, let's find the acceleration. Well, that would be the second derivative of position or the derivative of velocity, and that would give us the acceleration function, okay? So in this case, since the velocity function we figured out from up here is 2t minus 4, then if we take the derivative of that, that'd be 2. Now, what does that mean? That means that the acceleration is always going to be 2 meters per second, okay? So that means a of 4, the acceleration at time 4 would be positive 2 meters per second, or 2 meters per second squared. You can use either one of these units. They're both correct units, okay? Remember, acceleration describes how this velocity is changing every second, okay? And if we simplify this, That's how we wind up with this. Okay, so the acceleration at time t equals 4 is 2 meters per second squared. All right, let's go to the next problem. So now what we're going to look at is a position, velocity, and time graph from the previous problem, okay? So our position is still t squared minus 4t plus 3. Our velocity is 2t minus 4, and our acceleration is 2. And so we can use the graph to help us decide different things. So in this case, at what values of t does the particle change directions, okay? So we need to know that a particle changes direction when the velocity changes signs, okay? So we gotta look at the velocity function. So that's this line right here, 2t minus 4. And we know right here at 2, the velocity is 0. And just before that, the velocity was negative. And just after that, the velocity is positive. Now, it's really gonna be important that you're able to justify why. All right, because that's part of what calculus does, is it justifies why, okay? So we could say, at what time does the particle change direction? The particle changes directions at t equals 2. All right, now the why. Okay, so why are we saying this? And it's because v of t, the velocity, changes from negative to positive. Now, you could say it just changes signs, and that would be sufficient. But this is leading to something else that's coming up in the next couple of units. So I want to start by looking at how it's changing, okay? So it's changing from being negative to being positive. And it's not that it changes, but it's changing in that way at t equals 2. So we need to add at t equals 2. Now, it's got to be written up like this. Okay, no ifs, ands, or buts. It has to be written up like this. This is the proper way of writing it, okay, and giving a justification of why you're saying what you're saying. And that's a big part of calculus, is just justifying why you're saying what you're saying. It's not just some random thought that comes out. There's a reason why you're saying it, okay? All right, so when is the particle moving left? Well, how do we know that? We know the particle is moving left when the velocity would be negative, okay? So we know that from 0 to 2, now at 0, the velocity is actually negative. It's -4. So we're going to include time 0. However, we're not going to include time 2 at 2. Why? Because the velocity is not negative there, and that's what's telling us that it's moving left. Well, it's not moving left at 2. All right, because the velocity is 0. It's moving to the left just before 2, all right, but not at 2, okay? So the particle is moving left. Okay, and you can say this, I'm gonna do it different ways. I'm gonna do it with inequalities this time, okay? But you could also do it with interval, okay? If you're using intervals, you're gonna say on. If you're using inequalities, you're gonna say for, okay? That's the proper, okay? Now, is that gonna be that big a deal if you write for and it should be on? No, okay? The particle is moving left for 0 less than or equal to t less than 2. So we're including 0 because at time 0, the velocity is actually negative, but we're not including 2 because the velocity is not negative there, okay? So because, okay, v of t is less than 0, that's saying it's negative for 0 less than or equal to t less than 2. And that's how we know it's moving left, okay? So the next one I'm gonna do with intervals, okay? Just to show you could do it either way, okay? So when is the particle moving right? Well, we know the particle is moving right when the velocity is positive, okay? Once again, the velocity is not positive at 2, it's 0. So we're not gonna include it, all right? Now, after 2, just after 2, yeah, the velocity is positive. Right after 2, velocity is positive from there on out, okay? So when is the particle moving right? The particle is moving right. And if we're going to use interval notation, you're going to say it's on the interval, okay? So on parenthesis 2 comma infinity, because v of t is greater than 0 on that interval, 2 to infinity, period, okay? So you could replace this on with 4, and then we would say t is greater than 2 because v of t is greater than 0, and we would say 4 t is greater than 2. Okay, so that's, so in the red, you'd replace the on with the interval and the on the interval with those two, and you'd have it right. Okay, so I just want to, I do want to give you options. Okay, but the write-up needs to be correct. Okay, and you're telling me where it's happening, and you're giving me a justification of why you're saying what you're saying. Okay. All right. So the next question is this: when is the particle moving towards the origin? Okay. So how do you know you're moving towards the origin? Well, that's a combination of position as well as the direction of movement. So you have to look at position and velocity at the same time, okay? All right, so I wanna look at this, okay, a little bit differently, okay? If you look here from 0 to 1, okay, the velocity is positive, okay, but the position is positive and the velocity is negative, okay? So position is positive and velocity is negative. From 1 to 2, all right, the position is negative and the velocity is negative. From 2 to 3, the position, because this is position, is negative, but the velocity is positive, okay? And then from 3 on, okay, now the position is positive and the velocity is also positive, okay? So you have to look at this, okay? How do you know if you're moving towards the origin? Well, if you're on the right side of the origin, your position would be positive. And if you're moving towards the origin, you'd have to be moving left. So you'd have to be on the right side moving left to be moving towards the origin. So moving towards the origin, position would have to be positive and velocity negative. Or if you're on the left side, you'd have to be moving right. Okay, so if you're on the left side, you'd be on the negative position side of the origin, and then your velocity would have to be positive. So basically, opposite signs. Okay, so this is kind of like speeding up and slowing down. In this case, it'd be like slowing down. All right, so position has to be positive. Okay, position and velocity would have to be opposite signs. Okay, that's what I'm trying to get at. Position and velocity would have to be opposite signs, okay? Because if we're on the right side, okay, we would have to be moving left to be going towards the origin, or we'd be on the left side moving right, okay? So when are we moving to the origin? Okay, so I'm gonna summarize this, okay? Right here, from here to here, from 0 to 1, okay, I know that my position is positive. So S is for position is greater than 0, and my velocity is less than 0. All right. And then from 1 to 2, I know, again, my position is negative. So position is negative, and my velocity is negative. And then from 2 to 3, my position is negative. but now my velocity is positive. And from 3 to 4, from 3 to 4, okay, from 3 to 4, my position, actually from 3 on. Okay, so from 3 on, I know my position is positive because I'm above the t-axis, okay? So my position is positive and my velocity is positive from there on out, okay? So my s is greater than 0, my position is greater than 0, and my velocity is also greater than 0, okay? So let's interpret what this means. Right here, this means you are on the right side, but you're moving left. Right side, moving left. You're moving towards the origin, okay? This would mean you're on the left side, moving right. Okay, so you're on the left side. I'm sorry, you're on the left side and you're moving left. And then this would be you're on the left side moving right. So if you're on the left side moving right, you're moving towards the origin. Right here, you're on the right side and you're moving right. So right side moving right, you're moving away from the origin. Okay. So again, right side moving left, you're moving towards the origin. Left side moving left, you're moving away from the origin. Left side moving right, you're moving towards the origin. So it's these two intervals in which you are moving towards the origin. And look, you have opposite signs of position and velocity. Okay? So here we go to answer this, okay? So when is the particle moving towards the origin? Okay, so the particle is moving towards the origin, and I'm going to use interval notation on this, okay? It's just going to be easier. The particle is moving towards the origin on, okay, now 0 to 1, okay, so we're looking at the position, okay, and this velocity right here, okay? Now, we can't include 1 because at 1, the position is not positive or negative, it's 0, okay? So we're going to include 0 because at 0, the position is positive and the velocity is negative. So we're going to use a bracket and then 0, comma, 1, parenthesis. And we're not including 1 because it has to be, they have to be positive and negative, right? They have to be opposite signs. Well, at 1, the position is not positive or negative, it's 0. So we cannot include it, okay? So wherever it's 0, either the position or velocity, you're not going to include it, okay? All right. If they don't fit the situation, okay, then they're not, you're not going to include it. That's going to be really important, okay? So we're saying this one because, and it's because position is S of t is greater than 0 and V of t is less than 0, right? On the interval 0 to 1, okay? And it's moving towards the origin. There's another time it's moving towards the origin, and it's between 2 and 3. Now, in this case, 2 and 3, okay, the position is negative, so we're on the left side, but the velocity is positive, so we're on the left side, and we're moving to the right, okay? So, and 2 to 3, okay, and we're not going to include 2 because the velocity isn't positive there, and we're not going to include 3 because the position isn't negative there, okay? So, and 2 to 3 because, and we would say S of t is less than 0 and V of t is greater than 0. Notice it's saying greater than 0, right? Or less than 0. So when it's 0, we can't include it, okay? On either one of them. On the interval 2 to 3, period. All right. Okay. So now how about moving away from the origin? Okay. So it's going to be moving away from the origin when it's on the right side and moving right. That's where position and velocity would both be positive. Another situation where it could be moving away from the origin is being on the left side of the origin, moving left. So that would be the situation where you have position and velocity both being negative. Okay. So right here, right between 1 and 2, we have both position and velocity being negative. Okay. That would mean it's on the left side moving left, which means it's moving away from the origin. Okay. So the particle is moving away from the origin on 1 to 2. And we're not going to include 1 because the position is 0 there. And we're not going to include 2 because the velocity is 0 there. Okay. It's only in between these that they're both negative. Okay. Because S of t is less than 0 and V of t is less than 0 on 1 to 2. And there's another place, okay? From 3 on, the velocity and position are both positive. So that would mean that we're on the right side and we're moving right. So and 3 to infinity. And we're not going to include 3. Okay, so once again, why aren't we going to include 3? At 3, the position is 0. It's not positive. Okay, and this is, it's only from 3 on that the position and velocity are both positive. Okay, so and this interval, because S of t is greater than 0 and V of t is greater than 0 on the interval 3 to infinity, period. Okay, so that's how we know it's moving away from the origin. So the next two questions are asking when is it speeding up and when is it slowing down, okay? So now speeding up and slowing down has to do with velocity, the combination of velocity and acceleration, okay? So what's nice about this problem is the acceleration is constant, right? It's always 2. It's always positive, okay? So A is greater than 0 here, A is greater than 0, A is greater than 0, and A is greater than 0. The whole time A is greater than 0, right? Because it's 2, which is positive, which means it's greater than 0, okay? All right, so how do we know when it's speeding up? It's when the acceleration and the velocity are both positive or both negative. In other words, the same sign, okay? So right here, okay, right here, velocity and acceleration are both positive, right? And also right here. So really, okay, it's not, and the velocity is positive the whole time. From 2 on, the velocity is always positive and the acceleration is always positive, okay? So from 2 on, it's speeding up. Now, it's not speeding up at t equals 2. Why? Because you have to have them, the acceleration and velocity both be positive or both be negative to be speeding up. At 2, the velocity is not positive, guys. Okay, the velocity is 0. So we have to think about this, okay? So the particle is speeding up on the interval 2 to infinity because V of t is greater than 0 and A of t is greater than 0 on the interval 2 to infinity, period. So you're telling me when it's speeding up and you're giving me a reason why it's speeding up. Okay, now slowing down. Slowing down is when the velocity and acceleration are opposites, okay? So that's gonna happen right here, okay, between 0 and 1. but it's also happening from 1 to 2. So right here, the velocity is negative and the acceleration is always positive, except at 2, the velocity is not negative. The velocity is 0. So we can't include 2. Now, how about 0? Yeah, you could, because the velocity is -4 there. It is negative at 0, and the acceleration is positive at 0. So we're going to include 0, but we're not going to include 2, because one of those two is 0. Either if the velocity or acceleration is 0, we can't say that it's speeding up or slowing down at that moment in time, okay? All right, so when is the particle slowing down? The particle is slowing down on the interval 0 to 2, not including 2, because v of t is less than 0 and a of t is greater than 0 on that interval. Okay, so that's when it's slowing down. All right, so that's answering this question, okay? These questions, all right? And then I'm gonna do one more problem with you, because this was kind of a simple problem because the acceleration was always positive, okay? So for this next problem, we're gonna be looking at position, velocity, and acceleration, okay, again. And it's from 0 to 5. Actually, we're going from, on, but after 4, the behavior stays the same. That's what these arrows are telling us, okay? So they're both positive. After 4, all 3 things are positive, okay? All right, so this is the position function, and because we're moving along the x-axis, we're calling it x of t. All right, so this function right here is x of t is equal to t cubed minus 8t squared plus 20t minus 16. Okay, now I want to know when we're at the origin. Okay, so I need to set this equal to 0 and solve it. So t cubed minus 8t squared plus 20t minus 16. And I'm going to solve this graphically with a graphing calculator. You should know how to do that, okay? You just, you go into the calc feature of the calculator and you solve it for each of these values right here where it's crossing, okay? So then that would give you, I'm going to tell you right now, just reading off the graph, it'd give you t equals 2 and t equals 4. Okay, so this is the velocity graph. And so we know that velocity is the derivative of position. So v of t is 3t squared minus 16t plus 20. I want to know where the velocity is 0. Okay, so set this equal to 0. So that's 3t, 0 is equal to 3t squared minus 16t plus the 20. So this is going to happen at, and we would do this graphically too, it'd happen at t equals 2, and also at t is about 3.333. All right, and then acceleration is the second derivative of position, which is the first derivative of velocity. So this would give you 6t minus 16. Okay, now this one we could actually solve, and it wouldn't be that bad, okay? So 0 is equal to 6t minus 16. That's where the acceleration is 0. And okay, again, we're never going to want to include these when the position is 0, the velocity is 0, or the acceleration is 0. Depending on what I'm asking you, you're not going to want to include these values, okay? So that's going to be important. So this is going to be, t would be 16 over 6. So you wouldn't have to solve this one graphically, which gives you 8/3, which is 2.667. Okay. So the very first question is this: where does the particle start? Well, where it starts would be time equals 0. Okay, so that would be x of 0. That's what we need to find, x of 0. And so x of 0 would be 0 cubed minus 8 times 0 squared plus 20 times 0 minus 16. So that's telling us x of 0 is equal to negative 16. So it's starting on the left side, right? So the particle starts at x equals negative 16 on the x-axis. All right, something I like to do, okay, is I draw a timeline to help me figure everything out, okay? So I'm gonna start this at 0. I'm gonna draw my timeline. And every one of these x-intercepts for position, velocity, or acceleration, I would put it in this timeline. Those are the important times because that's where things are gonna change, okay? So we have one at 2. We have another one at 2.667. We have another one at 3.333. And then another one at 4. And then we have 4 on, okay? So from 0 to 2, okay, the position is negative, right? But not at 2. So x of t on this interval is less than 0, okay? From 2 to 4, the position is still negative, right? Now, it wasn't negative at 2 though, right? It was 0 and at 4, but it's still negative, okay? So x of t is less than 0 on this interval. X of t is less than 0. From 3.333 to 4, x of t is less than 0. From 4 on, the position is positive. So x of t is greater than 0. Okay, so now let's switch to velocity. Okay, so velocity from 0 to 2, the velocity is positive. So v of t is greater than 0. At 2, okay, velocity is 0, so we can't include that. And then from 2 to this 3.333, the velocity is negative. So v of t is less than 0, and v of t is less than 0. And then from 3.333 on, so these two, right, these two intervals, the velocity is going to be positive. So v of t is greater than 0. V of t is greater than 0. All right, and then acceleration. Okay, so now acceleration. So a of t is negative from 0 to 2.667. Okay, so it's going to be negative in these two intervals. So a of t is less than 0. A of t is less than 0. And then after 2.667, from these three, right, the acceleration is going to be positive. A of t is greater than 0, right? Okay, so this is telling us, if we can just learn how to interpret this, okay, this is telling me I'm on the left side, but the velocity is positive, sorry. Okay, so position is negative, velocity is positive, so I'm on the left side, but I'm moving right. This would be towards the origin, okay? I'm on the left side, okay, moving right. I'm sorry, moving left. I'm on the left side, moving left. I'm moving away from the origin. I'm on the left side and I'm still moving left. So I was actually at 2.667, right, which is right in here. The position is negative, and also right at 2.667, the velocity is negative, right? So we would include this. So we'd go all the way from here to include that interval, okay, of where the position is negative and the velocity is also negative, okay? So it's this whole interval. So we got to watch out on these, okay, whether to include them or not, okay? All right, and then right here, okay, I know I'm on the left side, but now I'm moving right, so I'm moving towards the origin again. And then right here, I'm on the right-hand side, and I'm moving right. So I'm moving away from the origin. Okay. And then here, velocity is positive, but acceleration is negative. I'm slowing down. Okay. I wouldn't include 2 because 2 is 0 for velocity. Okay. Here, velocity is negative, but the acceleration is also negative. That's telling me I'm speeding up. Velocity is negative, acceleration is positive, so I'm slowing down here, okay? And here I'm speeding up, but here I'm slowing down, okay? And then here I'm speeding up again because at 3.333, I stopped, right? At 3.33, okay, that's right here. And then velocity is positive and acceleration is both positive. So now after 4, I'm speeding up again, okay? All right, and here I'm speeding up. So actually, I take that back. From 3.333 on, I am speeding up, okay? Because the velocity and the acceleration are both positive. Even at 4, look, the velocity is positive and the acceleration is positive, right? So we are speeding up. From 3.333 on, we are speeding up. So it's this whole interval from 3.33 on that we're speeding up. Okay, so here we go. Let's answer all these questions, okay? So when is the particle moving to the left? The particle is moving to the left when the velocity is negative, right? Okay, so that would be when the velocity is negative is between 2 and 3.333. Now, what about 2.667? Okay, that had to do with the acceleration, right? So it's going to be all the way from 2 to 3.333 that the velocity is negative. Now, we're not going to include 2 and we're not going to include 3.333, okay? So we're not going to include those 2 points. Why? Because the velocity is not negative there, okay? So here we go. When is it moving left? So the particle is moving left. On the interval 2, 3.333. Because v of t is less than 0 on this interval 2 to 3.333. Once again, do we include 2? No, because the velocity, we're saying it's moving left because the velocity is negative, and the velocity is not negative at 2, and it's not negative at 3.333. That's why I'm not including them, okay? Where's the particle moving to the right, okay? That's the next question. So let me zoom out a little bit. I know this takes a long time, guys, okay? So hang in there. The particle is moving right on, okay, so we're looking for where the velocity is we're just looking at velocity and we're only looking for where it's positive, okay? So it's positive right in here and also in here, okay? So we're gonna, now what about 0? Do we include 0? Yes, because the velocity is positive there, okay? But we don't include 2 because the velocity is 0 there, it's not positive, okay? So it's moving to the right on the interval 0 to 2, including 0 because the velocity is positive at 0, but not 2 because the velocity is 0 at 2, okay? And we could throw in a union or you could write an and, okay? Union, and then 3.333, and we're not going to include 3.333 because the velocity is not positive there, okay? And then comma, infinity, because v of t is greater than 0 on those 2 intervals, 0 to 2, union, parenthesis, 3.333, comma, infinity. And that's why we're saying it's moving to the right there. Okay, where does it change directions? Okay, all right, so it changes directions at t equals 2 because it changes, the velocity changed from positive to negative, and then it also changed directions at 3.333 because the velocity changed from negative to positive, okay? All right, so I'm going to slide it up a little bit. Okay, so the particle changes directions at t equals 2 and t is equal to 3.333 because v of t, and I'm just going to say it's those two because v of t changes signs. And I'm fine if you say that. Okay, v of t changes signs at t equals 2 and t equals 3.333. Okay, you cannot just say, oh, v of t changes signs. No, it's that the fact that it's changing signs at those two values is why we know it changes directions at t equals 2 and t equals 3.333. Okay, so if you leave off the at part right here, I'm going to mark you wrong, and I don't want to, okay, but I'm going to because it will be wrong on the AP exam too. You got to include this. It's the fact that it's changing sign. It's incomplete English is what it is, okay? You're not making a complete statement, okay? It changes signs. Yeah, but it's changing signs at those values is why, okay? All right, let's go to the next one. So turn the page. So you guys, I've copied over my timeline that I made on the previous page just to help us answer this. Usually I just refer back to it and I go back and forth, but I thought that might be hard for us doing this virtually. Okay, so I kind of copied all this over just to look at this, okay? But usually I just go back to refer back to the previous page, okay? So here you go. When does the particle slow down? Okay, so how do we know when it's slowing down? We know it's slowing down when the velocity and the acceleration are opposite signs. Okay, so right here from 0 to 2, okay, from 0 to 2, I know my velocity is positive and my acceleration is negative. Now, we gotta be worried about these endpoints, right? At 2, okay, so we're not gonna include 2, definitely, because the velocity is 0 there, right? Okay, so it's slowing down here, okay? But then from 2 to 3, or 2 to 2.667, okay? And even onwards, right? This is telling us that it's speeding up. And then here, it's slowing down. Now here, the velocity is negative still, right? Okay, but now the acceleration changed and now became positive, okay? So it is slowing down from 0 to 2. It's slowing down from 2.667 to 3.333, and then it's speeding up. And then after 3.333, it's speeding up the entire time, okay? All right, so when is it slowing down? So the particle is slowing down on, okay, so now do we include 0, okay? So you got to always look at, okay, so we said 0 to 2, but you always got to take a look at what's happening at 0 and what's happening at 2. At 0, the velocity is positive, and at 0, the acceleration is negative. Yeah, it is slowing down at time 0, okay? So we're going to include it. So 0 to 2. Now at 2, do we include it? Well, at 2, the acceleration is negative, but over here the velocity is 0. Well, it's not opposite signs then, right? So we're not going to include 2. Okay, and we'd say because, and it's because the velocity is positive, but the acceleration is negative. Okay, because v of t is greater than 0 and a of t is less than 0. Okay, and you guys on, and I should say on, bracket 0 to 2. And I don't know if you guys are noticing this, but I notice it, okay? I'm slowing down, right? And you're like, why is he taking so long to say stuff? Because I have to think through this just like you guys do, okay? I have to think about the combinations of stuff, and then I also have to worry about the endpoints, okay? So I'm going through this with you as if I'm doing it, okay? So just know I'm thinking along with you guys right now, okay? That's why you might see me go, because I'm thinking, all right? So right here, okay, from 2.667 to 3.333, my velocity is negative, right? and my acceleration is positive. So I'm slowing down here, but I'm not slowing down here, and I'm not slowing down before that, right? So I'm looking at these two, okay? 2.667, the velocity is negative, okay, but at 2.667, the acceleration isn't negative or positive because it's 0, okay? So I can't include this 2.667, okay? I also can't include 3.333, okay? Because at 3.333, the velocity is 0, the acceleration is positive, okay? So it's slowing down also on this interval, 2.667 to 3.333 because v of t is less than 0 and a of t is less than 0 on 2.667 to 3.333. Parentheses. Okay, when is it speeding up? So speeding up is when the velocity and acceleration are either both positive or they're both negative, okay? So it's not happening here. It is happening here, okay? So is it speeding up at 2, okay? So at 2, no, because the velocity is 0 there. So we're not going to include 2. Is it, how about 2.667? 2.667, the acceleration isn't positive or negative there, right? So it's 0. So we're not going to include either of these endpoints, okay? So the particle is speeding up. On the interval 2, not including 2, to 2.667, because on that interval, v of t is less than 0, and a of t is less than 0 on the interval 2 to 2.667. And there's another place it's speeding up. Okay, so it's not speeding up here because they're opposite signs, but here they're the same sign, right? So, and here they're the same sign. So, all right, so you may, when you have two intervals side by side to each other, you may not break it at 4, okay? So at 4, the velocity is positive, and at 4, the acceleration. So it's actually a bigger interval. It's not two intervals here, okay? It's one big interval, okay? So it's really 3.333 onward, okay? So now the question is, do we include 3.333? No, because the velocity is 0 there. It's not positive, okay? All right, so and 3.333 to infinity, because v of t is greater than 0 and a of t is greater than 0 on the interval 3.333 comma infinity. All right, we have this 4 here, right here, because of position. All right, that's why the 4 is there. Okay, so here's the next question. All right, when is the particle moving towards the origin? Well, we have to look at it being on the right side and moving left, which means positive position, negative velocity, or we have to be looking at the left side moving right. So that'd be negative position and positive velocity, okay? So basically we're looking for opposite signs for position and velocity. So if you look right here, position's negative, velocity is positive. Okay, so it's moving towards the origin right here, okay? All right, but it's not moving towards the origin here, right? Because the position is negative and the velocity is negative. So we're on the left side moving left. So here we're on the left side moving right. From 0 to 2, we are on the left side and we are moving moving right. So we're moving towards origin. See, that's what I'm talking about. Like, did you see my hesitation right there? So we're, because I'm thinking we're on the left side and we're moving right. Okay. So that means moving towards the origin. Okay. So the particle is moving towards the origin. On, okay, and we would include, well, it's the interval 0 to 2. Now, do we include 0? Okay, so if we look at 0, the position is negative, and at 0, the velocity is positive. Yes, we're going to include 0 because it fits the reason why it's moving towards the origin. Okay, how about at 2? No, because the position is 0. It's actually at the origin at time t equals 2. So if you're at the origin, you can't be moving towards it if you're at it, right? So that's why we can't include 2, because the position isn't negative there, right? So we're not going to include 2. And then we'd say because x of t is less than 0 and v of t is greater than 0 on the interval 0 to 2, including 0, but not including 2. All right. Is there any other place? Okay. So, all right. So right here, position is negative, velocity is negative. That's moving away. Position is negative, velocity is negative. We're moving away because we're on the left side moving left. Here, we're on the left side, and now we're moving right. So we're moving towards the origin again here, right? And here, position, we're on the right-hand side, and we're moving right. So we're moving towards the origin right here between 3.333 and 4, okay? So, and 3.333, comma, 4. Now, how about 3.333? Okay, do we include it? Well, at 3.333, the position is negative, but the velocity is 0 there. We cannot include it, okay? All right, because there's no motion at exactly 3.33. We're not moving. We're actually stopped, right? So you can't be moving towards it if you're stopped, okay? So that's why we're not going to include 3.333. How about 4, okay? At 4, the velocity is positive, but the position is 0. We're at the origin. If you're at the origin at 4, you can't be moving towards it, okay? So we're not going to include 4 either, okay? So the particle is moving towards the origin on this interval because of this, and 3.33 to 4 because x of t is less than 0 and v of t is greater than 0 on 3.333. Comma 4. Now, I'm going to tell you right now, you could have written this all in one statement, okay? You could have cleaned this up with English-wise a little bit, okay? You could have said this and it would have been perfectly fine. The particle is moving towards the origin on 0 to 2 and 3.333 to 4 because x of t is less than 0 and v of t is greater than 0 on the interval 0 to 2 and 3.333 to 4. And okay, because it's the same reason for both of these, okay? You would have to break it up, okay, into I'm going to be honest with you, I like it when you guys just do separate sentences, like for each one, okay? And so that's just because it's cleaner, okay, and it's easier to read, all right? But you could, alternatives, you could say this interval and this interval because of this, because it's the same reasoning for both, on these two intervals, and then you could be done with it, okay? All right, last question, okay? I know this takes a while, all right? Believe me, I know. I'm recording it. I know I'm doing it with you, okay? When is the particle moving away from the origin? Okay, so we know it's moving away when it's on the right side, moving right. So positive position, positive velocity. Or it's also moving away from the origin when the position is negative and the velocity is negative, because then you're on the left side moving left, okay? So we have to have the same sign, all right? So if you look, okay, 0 to 2, that was moving away, right? How about here? Okay, 2 to 2.667, okay? And then 2.667 to 3.333. Now, if you look, you got to ask yourself, okay, they're both negative here and they're both negative here. Do we include the whole thing, or is it two separate ones? Okay. And then over here, we're moving away again, right? Because we already included we already know this interval right here is moving towards, okay? So here we're moving away again, right? And it's because the position and velocity are both positive, which means you're on the right side moving right. But right here, do we include, is it two intervals or is it one big interval? Now, this is where people have a tough time, okay? So if you look at this, okay, we're saying the position is negative from 2 to 2.667. Yeah, it is, okay? And all the way to 3.333, okay, right here. Yeah, the position is negative the entire time, right? And how about velocity? Okay, so the velocity, is it negative the entire time from 2 to 3.333? Yeah, it is, right? So we're going to include this whole big interval, okay? It's really not two of them. It's really just one of them, okay? So the particle is moving away from the origin on, okay, so the interval, we're going to start it at 2. At 2.667, okay, and we're saying the position and velocity are both negative. At 2.667, the position is negative and the velocity is negative. So we're not going to break it up again, okay? We're going to go all the way from 2 to 3.333. But do we include that 2? No, because the position is 0 there, okay? So we're not going to include 2. Are we going to include the 3.333? Well, 3.33 position is negative, but the velocity is not negative. It's actually 0 there, right? So we're not going to include 3.333 either. Okay, because x of t is less than 0 and v of t is less than 0 on the interval 2 to 3.333. And there's another place, okay, that's moving away. It's moving away on this interval, okay? So, and 4 to infinity, at 4, what's happening, okay? So at 4, the position is 0. We're at the origin at 4 seconds, okay? So we're not going to include 4. And we're not going to include infinity, okay? Because after that, the position is going to be positive, and after 4, the velocity is always going to be positive, okay? You can look at that by the graph. I'm referring up here, okay? So position is positive here, and position is positive here, right? So they're both positive. That means it's moving right. You're on the right side moving right, which means you're moving away, okay? So, and 4 to infinity, because x of t is greater than 0 and v of t is also greater than 0. Okay. All right. On the interval 4 to infinity. Okay. And that's how you determine all of this stuff. It doesn't get any harder than this. Okay. This is like one of the hardest ones to do because the acceleration is changing. The previous example I did with you guys, the acceleration was always positive, so it made it a little bit easier to handle. Okay. All right. So one of the big things, let me zoom out a little bit. Okay. One of the big things is determine your x-intercepts for position, velocity, and acceleration. And you can make this timeline. I have never heard of the timeline. It's something I've come up with that helps me, and it's helped my students just to organize everything and realize what's going on. So all of these values are either x-intercepts for position, velocity, or acceleration. And just sometimes the signs are the same. So it's a bigger interval like we just looked at, right? It's a bigger interval than just each of these individually, okay? Like right here, position and velocity are both negative, but it's not two separate intervals, okay? We don't want to think of that. It's actually one big interval, okay? Same thing with like velocity and acceleration over here, right? We're getting all of these because of all of the x-intercepts, right? But right here, the velocity and acceleration are both positive, not on two separate intervals, but it's really just one big interval, okay? All right, guys, that's it for today, okay? That was a long lesson, I know. Maybe not quite as bad as the first day, all right? All right, you guys have a great day. Take care.